Hi everyone, we're going to graph 5 absolute value functions with transformations, and then I put in a 6th graph to put it all together. Recall that the definition of an absolute value function is as such. This is called a piecewise function, and it just means when you have a value of, say, if we have a value of 2, that means 2 is greater than or equal to 0. That means I use this x here. So that will just be 2. However, if I have a value of negative 2, I'm going to have to use that. This is negative. We have to use this piece because negative 2 is less than 0. And I plug it into this value. So that's negative times a negative 2, which gives us a 2. Basically, this is just the definition. All right, so just remember that. And we're going to start graphing a reflection. So this is called a reflection. I already took the liberty of making the table of values. And basically, this is your y part. And I already drew the parent function. And we want to reflect this. So basically, since absolute value of x is our y, then, because it's y equals negative absolute value of x, it says it equals that, we're just saying negative y. So all I'm going to do is take my y values here and negate them. So that's going to be negative 2, negative 1, 0, negative 1, and 2. And then I'm going to graph this piece, this x, with our new y. And basically, it's basically 2 linear lines put together as we discussed. And I'm just going to plot some points here. And it's really hard to graph on this, so please don't complain about the graphs. But it's just like a slope of negative 1, and you just go down this way and go down this way. It's a reflection over the, let me do it, over the x-axis. Okay? The next one is going to be a horizontal shift. Oh, let's go back to this. Let's talk about the domain and range. The domain is still all real numbers. So the domain, and I'm going to go ahead and write it this way. X, that tells you it's the domain. So X is all real numbers. That's a C with a line through it. It's inclusion sign. And the range is our Y values, is Y is less than or equal to 0. And it's a reflection. Okay. Now, this one we're going to do a horizontal shift to the left by 2. Because recall that this is going to be a horizontal shift to the left by 2 units. I'm going to have to erase this, but because recall this is really x minus a negative 2. This part right here. Anyway, so I use my normal values for the parent functions here, and then what I'm going to do here is subtract 2 from this 2 here, and I get negative 4. Subtract 2, I get negative 3, negative 2, negative 1, and 0. And I'm going to graph this x with this y. This is your y. And you can do the table, or you could just shift all these points over by 2 to the left. So from here, you could just go over 2. And once you go over 2, and this, you know the slope is 1, all you have to do is do rise over run. We know we have the positive portion, so rise over run by 1. And graph it this way. And then we have the negative portion, so we're up and over. Up 1 over 1, up 1 over 1, up 1 over 1. So you could just graph it like that. And we just shifted the whole graph to the left by 2 units. Okay, let's look at the domain. domain. So that would be all real numbers. Again, I can put any numbers I want in my table of values. And it looks like my range, it's still positive. So y, it never goes below the x-axis here when you're looking at it. So y is greater than or equal to 0. And it is a horizontal shift. Okay. Now this one's going to be a vertical shift up by 2 units. Vertical shift up by 2 units. Maybe I should write it down here because we're going to be going up. So let me write it down here. Vertical shift up by 2. And I didn't plug these in, so I'm just using -2, -1, 0, 1, 2. The absolute value would be 2, 1, 0, 1, 2. So all we're doing is we're adding 2 to the y. This is our y. And we're adding 2 to the y. So this would be 4, 3, 2, 3, and 4. Or again, all you have to do from the 0 is go up 2, because if you know what it looks like, I didn't write this up. This is going to be y equals absolute value of x plus 2. Up 2, and then you know your slope is 1. So you go up 1 over 1, up 1 over 1, and kind of graph it, the slope of 1. And for the left side, up 1 over 1, up 1 over 1, and so forth. And just kind of grab the corners of the squares as you go up. Okay? Domain is x, such that x belongs to all real numbers. We can put any numbers here. But our range changed here. Our range is y, but now, since we shifted this up, we're going to say y is greater than or equal to 2. And it's a vertical shift up by 2 units. Okay? Now this one's going to be a vertical stretch by 2, and I'm going to hurry up and put my values in. Take the absolute value. This is my y. And I'm going to multiply my y, which is absolute value of x, by 2. So I just multiply this by 2. So 2 times 2 is 4. Let me put it in red. 4. 2 times 1 is 2. 2 times 0 is 0. 2, 4. You just multiply this column here by 2. And I'm going to plot the points now. So 0 still goes to 0, 0. 1 now goes to 2. And 2 goes to 4. All right? And I can also go this side. Remember, this is symmetric about the y-axis, so you can kind of guess. This just means it looks like a linear a little bit. It just means my slope is 2, so I'm going up 2 over 1, up 2 over 1. So that's a stretch. Up 2 over 1, up 2 over 1, up 2 over 1. Or you can just make it symmetric to the right side. And that's what a vertical stretch is. A vertical stretch is like holding a rubber band and you're stretching it and it makes it longer looking. Vertical stretch by 2 units. Okay, the last one is very similar. This is going to be y equals 1/2 absolute value of x. And this is called a vertical compression. And I'm just going to put in my normal parent function values. And this is my y. So I'm just taking 1/2 of my y here. Because this is my y. And I take half of everything. And I'm going to get half of 2 is 1. Half of 1 is 1/2. And then it repeats. It's symmetric. And I plot this. So 0 still goes to 0. 1, however, goes to 1/2. And 2 goes to 1. And another way of seeing this is that the slope is 1/2. So we're basically going up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. So that would be your slope. And you can either make it symmetric or kind of do the same thing. Up 1 over 2, up 1 over 2, up 1 over 2. I kind of have to draw the dots because it's hard to write on the iPad here. All right? This is called a vertical shrink. Or compression, depending on, it's the same thing. Vertical shrink or compression by 1/2 units. Okay, I'm going to do the last one very quickly, not using a table. We're going to put it all together. We're going to do a reflection, a stretch, horizontal shift to the right by 4, and a vertical shift down by 4. You should have already seen the video on the vertex that we did. We know our vertex is going to be 3, -4. So I'm going to plot that first. 1, 2, 3, -4. 1, 2, 3, 4. So this is where we're starting. We've already taken care of this bit and this bit. Now the negative just means we're going to go down. So it's going to be going down this way. All right, that's all you have to know about that. I'm not even making a table. But the slope is 2. So from this point, what we're going to do is we're going to go down 2 over 1, down 2 to the right, just make it symmetric. So from here, you're going down 2 over 1, down 2 over 1. Do you see how I'm making it symmetric? And it would be something like that. And that's all the transformations put together. Okay, the next thing we're going to do is do more graphs of these in vertex form. We're going to do 1, 2, 3, 4, about 5 of these.